Hello class, today we're going to talk about section 6.6, which is organizing data into matrices. By the end of today's lesson, you will be able to find the dimensions and the position of an element in a matrix. You'll be able to organize systems of equations into a matrix, and you will be able to perform matrix operations. So a matrix is a rectangular arrangement of numbers in rows and columns, and it's enclosed in brackets. We can use this to help us set up systems of equations. We aren't actually going to use this to solve the systems right now. That's something that you will get to in your Algebra 2 class in high school, but we just want to familiarize you with what a matrix is going to look like. Each number inside of a matrix is called an element, and then the dimensions are the size of the matrix. We refer to it as an M by N matrix, where M is the number of rows, that's going horizontally, and N is the number of columns, that's going vertically. So the first thing we want to talk about with matrix is dimensions and positions. So when we are looking at the dimensions of this matrix, we have 3 rows going across. So we've got 3 by, and I've got 4 columns going down. So this is a 3 by 4 matrix. Then when it gives you an element like this, or potentially in problems, you will just see it circled like that. That is when it is asking for you to describe the position of that particular element. So we've got row 1, so we'd refer to this as R1 and column 2. So R1, C2 stands for row 1, column 2. Again, another example of this, if I'm looking at element -1, I'm looking at, this time, row 2 and column 1. Now, how does this relate back to our systems of equations that we've been looking at? What this is saying is if I actually had the equations behind this matrix, this first line would be saying 7x minus 9y plus 5z is equal to 3. The second row would be saying -1x plus 3y minus 3z is equal to 6. And this last row would be saying 0x minus 4y plus 8z is equal to 2. So this is going to help you in high school when you start to get into these more complex systems of equations, but we're introducing it right now so that you are familiar with it and able to use it when you need to. So go ahead and state the dimensions of this matrix and then identify the position of this circled element right here. Dimensions are 1 by 4. There's only one row and there are 4 separate columns. And then our circled element is in row 1, obviously, since there's only one row, and column 3. Part of what you also will have to do is to create the matrix yourself. So at a swim meet, the teams earn the following scores. North has 10 in freestyle, 8 in backstroke, 8 in breaststroke, and 10 in butterfly. South has 5 in freestyle, 5 in backstroke, 10 in breaststroke, and 8 in butterfly. And West has 8 in freestyle, 10 in backstroke, 5 in breaststroke, and 5 in butterfly. Organize the matrix and then give the dimensions. So we have 3 different schools that we're looking at: North, South, and West. So that means that we are going to have 3 rows in our matrix. So I'm going to have row 1, row 2, and row 3. You don't need to draw those arrows in. I'm just giving you very specific directions on how to do this. So when we're looking at North, we have 4 different events: freestyle, backstroke, breaststroke, and butterfly. So we're going to take and we're going to plug in those North scores, starting with 10 for freestyle, 8 for backstroke, 8 for breaststroke, and 10 for butterfly. So we've got our 4 different columns now. All right, then we're going to do the exact same thing with South. Since freestyle was first for North, I want to make sure I list freestyle first for South. So 5 for freestyle, 5 for backstroke, 10 for breaststroke, and 8 for butterfly. and then I've got west is 8 for freestyle, 10 for backstroke, 5 for breaststroke, and 5 for butterfly. So now I have my matrix drawn up. The last thing it asks us to do is state the dimensions. So I've got my 3 rows by my 4 columns. So this is again a 3 by 4 matrix. Go ahead and drop a matrix for this one on your own. When you are done, just type done into the answer box and check your answer. So we've got our matrix, and it ends up being a 2 by 2 matrix. If you have questions about how to organize these, please let me know when you get to class. Next thing we have to talk about is the matrix operations. We are just going to be doing simple operations. We aren't going to be doing anything to solve them yet. So when we are doing these matrix operations, you can either add or subtract them, but they must be the exact same size. So if they do not have the same dimensions, you cannot perform these operations. So, for example, we are looking at A plus B right now. A is a 2 by 2 matrix, and B is a 2 by 2 matrix. So we are able to perform these operations. So what we want to do now is create another 2 by 2 matrix. That's going to be our answer. And we're going to look at each corresponding element. So we've got the first and the first. So I want to add those up, and I get 10 plus negative 4, which gives me 8. Then I'm going to look at the second ones. So I've got 2 and 4. So we're going to add those up and get 6. We're going to look at the next pair. Negative 9 plus negative 3 gives me negative 12. And our last pair of 15 plus negative 10 to give me 5. So when I add matrix A and matrix B, I get 8, 6, negative 12, 5. Next, it wants us to look at B minus C. B is a 2 by 2 matrix, while C is a 2 by 1 matrix. Since these two do not have the same size, this is not a possible matrix operation. There is nothing to match up here, so this is not possible. Go ahead and try this one on your own, subtracting matrix A from matrix C. We get 3, 1, 3, negative 7, 2, negative 1. If you have questions about that, please let me know when you get to class. Last thing we have to talk about is a scalar. This is another type of matrix operation where we are using multiplication. So the scalar is just like any other number that we would multiply with. It's just got a specific name. And scalar multiplication means multiplying each element in the matrix by the scalar. So essentially what this is saying is we've got a giant distributive property going on. So if A is 2, negative 4, negative 7, 9, 1, negative 10, 8, 6, we want to find 4A. So this 4 over here is our scalar, and what that means is I need to multiply each element in the matrix by a value of 4. So we're going to start with 2 times 4, which is going to give us 8. Negative 4 times 4 is negative 16. Negative 7 times 4 is negative 28. 9 times 4 is 36. 1 times 4 is 4. Negative 10 times 4 is negative 40. 8 times 4 is 32, and 6 times 4 is 24. So we've just taken the whole matrix and multiplied it by a scalar of 4. Go ahead and try this one on your own. Being careful that you use that negative when you are multiplying, you should have gotten 27, negative 9, negative 15, 33, 6, negative 21. If you have questions about this or anything else from the lesson, please let me know when you get to class.